Mrs. Solution is back, helping you with the little geometry. All right, so we have dilations in the coordinate plane. I'm gonna start with this first problem. Quadrilateral GHI to quadrilateral GHIJ prime. So because I didn't feel like counting on a video, I decided to write out the ordered pairs. So here we know that GHIJ is the original or the pre-image because it doesn't have those little tick marks on it. So we know we started here, and this is our image after we did the dilation. So let's compare the numbers, okay? We all know that a dilation is when an image is getting smaller or bigger. So here, if we compared here from -10, comma, -6, and now after the dilation, we have -5, comma, -3. Is this image getting larger or is it getting smaller? If you said it's getting smaller, you are correct. So we know that when we're working with dilations, we're either multiplying by a scale factor, okay? Now, if your image is getting larger, you multiply by a scale factor that is greater than 1, okay? Now, when your image is getting smaller, you're multiplying by a scale factor that's less than 1. So what numbers are less than 1? Duh, fractions. So our scale factor is less than 1, hence fractions. So you need to keep that note. So here, if we see that our images are getting smaller, we know that we're multiplying by a fraction. So let's figure out what our fraction is. I go from -10 to -6, and then I end up with -5, -3. Well, I know that's half, okay? So I'm really multiplying by 1/2, a scale factor of 1/2. Remember, multiplying by a fraction is also dividing, okay? So that's how I know my scale factor is 1/2. And this should work for all of my points because it's being applied to every single point in this quadrilateral. So if you see here, if I take half of -8, -4, I get -4, comma, -2. And it will work with all of your points, okay? Let's come over here to this next problem. We're going from quadrilateral KLMN to quadrilateral KLMN prime. So let's look at our points. 0, -2 to 0, -6. Do you think it's getting larger or smaller? Well, if you evaluate where we're starting from and look at where we end up, we notice that our image is getting larger because the numbers are bigger. So now we know that we have a scale factor that's greater than 1, okay? So what number should I multiply these numbers by to get my post image? Well, let's see. -2 times what will give me -3? -6. Well, 3. So if we multiply these numbers by 3, does it work for all of my points? Absolutely. So we have a scale factor that is greater than 1, and it's getting larger, so I know that my scale factor is 3. 3 times 3 will give me 9. -2 times 3 will give me -6. So that works here. So let's synthesize what we just talked about right here by answering these 3 questions. What happened to a shape when it is dilated by a scale factor that is less than 1? Less than 1 means fraction. So that means that our image is getting smaller. Image is getting smaller. All right. Describe the relationship between the size of a shape and its image after a dilation of a scale factor of 2. So a scale factor of 2, is 2 greater than or less than 1? Well, if you said it's greater than 1, you're absolutely correct. So if I had to describe this, I would say that all of my sides are getting larger by 2, or they double, because doubling means times 2. All right, now explain why dilations are not rigid motions. Well, are you moving anything? No. A dilation, the definition of a dilation is to get smaller or bigger. So that's your shape. So you're not moving it anywhere. So dilations are not rigid transformations. They're not moving. Motion means to move. So we know that the rigid transformations are reflections and translations and rotations. Well, dilation is a transformation because it changes your pre-image to another image, but it's not one that moves. So that's how we know. I hope this helps. Peace.